Okay, so here's a video. It's going to take a little bit longer. Got some calculations to do and some conceptual stuff. First, we're given this reaction and a change in enthalpy. Looks like it's positive, so it's going to be endothermic. That's the first thing I'll say for each one of these. It's positive, so it's going to be endothermic. Secondly, let's look at this. If we suppose that we have 99.2 grams of ammonia, which is here, suppose that much reacts. Will any heat be absorbed or released? And yes, it's going to be absorbed because it's positive, right? It's endothermic, so heat is going to be absorbed. Since it's, now we say we have to calculate it. Okay, not so easy now. Now I got to set up a calculation, and this is going to be a challenge. I did put this thing up here for whiteboard already, okay? It's going to be a challenge. So what I'm going to do is I'm going to say, I'm just going to set up a picket fence. And it's going to end up with kilojoules. That much we know. Now let me come over here and say, well, I've got kilojoules here. It looks like I've got that many kilojoules per, and we're being asked about ammonia. So it looks like I've got kilojoules, that many kilojoules for every 2 moles of ammonia. It looks like it's 160 kilojoules for every 2 moles of ammonia. And I was given this many grams. Oh, this is not so bad. Okay, so if I was given this many grams, and I know my grams per mole because I can look it up. Oh, I'm done. There it is. Those guys, I don't even need these. See that? My grams cross off, my moles cross off, and I'm left with kilojoules. So let's put these numbers in here then. 99.2. And this is going to be about 17 because ammonia is about 14 and hydrogen is about 1 each. So it's going to be 17 grams per 1 mole. And I'm basically done. Yeah. So I'm actually going to estimate this before I put it in my calculator. 99.2 is about 100. And 100 times 16 is 160 is about that. Divided by 34. Right? 2 times 17 is 34. I can't do that in my head. 34 is about 1/3 of 100. So let's see if we got rid of that and we said 3. 3 times 160, 480. Okay. So, I estimated maybe it's going to be close to 480. Let's go look at the calculator. Calculator says 99.2, right? Divided by 17. Divided by 17. Oh no, it wasn't 17. It was the molar mass. Let's do this whole thing. In case you haven't seen this yet, you're going to die. The molar mass is nitrogen plus 3 times hydrogen equals about 17. Got it. Store. Okay. Clear. Now let's go back to 99.2 divided by, recall, 17 times 160. Yeah, it's right there in front of me. And then also on the bottom was 160 per 2 moles of ammonia. Let's just go back over there. You see what I did here? 99.2 grams of ammonia. But ammonia is 17 grams per mole of ammonia. And there was 2 moles of ammonia up there, right? 2 moles of ammonia for every 160 kilojoules. So I'm left with kilojoules, and that's what I wanted. All right. So I'm back over here. 160 divided by 2 equals something close to 480. Yep, 466. Perfect. And it says to the correct number of sig figs. So let's go back over here. I have 3 sig figs here. There was a bunch here in my calculator. It was maybe 6 or 7. Let's just say 6 sig figs. There was 3 sig figs here, and this was an exact number. So it looks like I'm gonna, and exact numbers don't have any play, and this is a lot of sig figs. So it's gonna be 3 sig figs total. Remember, my calculator didn't say 17. It said 17.0 blank blank blank, right? So this is gonna be the 3 sig figs. It's gonna be 466. 466. Looks like it rounds down, and we should be good with that. Okay, hope that helps.